Now, let's talk about data definition commands. Data definition commands are used to define the structures for, let's say, organizing the data in a relational database. Imagine that you need to manage thousands of, or let's say millions of papers. Either you can, just pile it up and then look for one particular report out of that, and then you probably end up the whole day looking for that particular report. Or what you can do, you can organize the paper or the report based on the name, or let's say the type of report, though, or keep those bundles of report in a shelf by a particular name. The same idea is applied in organizing the data in a relational database as well. In the relational database, we basically structure the data using tables, which is a collection of related records, or let's say the data, right? And then we have indexes. Indexes are a set of data which really mentions the location of that particular data, similar to what we see in the index as within a books, right? So when you open a book, you will see the indexes, and it shows on which page you will see a particular topic. So in the same way, we have indexes in SQL as well. Then we have views, which are used when we repeatedly want to fetch the same set of records, or let's say the same data from one or more tables. And last but not the least, we have schemas, which are really the collections of, let's say, the tables, indexes, value or views, and some other data structures. I think I have mentioned previously as well in another SQL tutorial that schemas are basically the structure of the database as a whole, right? It defines how a table is created, or let's say the columns, and then you have indexes, which all tables have indexes, and then the list of views will also be there. So let's start with the tables, right? And then we will go, or we will take it one by one. So this is what a table look like, or let's say, a table is created. So before that, let me show you how a table actually looks like, so that it will be easier for you to understand. So let me take this one. So basically these are the list of tables, right? And then this is a database, and within the database you have tables, right? So these are created by me only. Now if I drag this over here, I'm just doing this for the sake that you understand it. So select star from DBO NSE extended. I think there is no data in this. Yeah, there's no data in this. Let me take another data table, right? So I think we have NSE. This is how our table looks like, right? So we have the rows, and then we have columns. So we have multiple columns, right? So now how this table is created is again a good thing to know. See, being a data analyst, you will be given a table, or let's say multiple tables, and then out of, or let's say the architecture, and then you have to combine multiple tables to create the data out of that, or let's say a select query. So this is how a table is created. So basically I have created I'm creating another table which basically says NSE extends. We have ticker. So I'm creating the same table but with a different table name. Right, so at the top you are mentioning which database to use, and then you can right now you can ignore all these, and then you have ticker, description, price, technical rating, and then here if you see we have nvarchar 50, which is a not null. So what does it mean? Basically nvarchar is a data type, so this will take multiple types of data, let's say numbers, and then text, even the dates, even though the date will not be specified as a specific date column. So yeah, like I mentioned, the ticker and varchar can have multiple types of datas, like the text, number, float, and many other data types, or let's say the characters, not the data type, because nvarchar itself is a data type. It can have only 50 number of characters. That's why we write how many characters it should have. It's more about space management, because if you write somewhere like, let's say 500, or let's say 5000, then and if this particular table will not have more than 50 characters, and it's a waste of space, right? So it's always recommended, right? And then it's a non-nullable column. So when it says not null, it means this column needs to have a data all the time. So whenever you insert the data into this table, this ticker should have the data. And similar to that, we have description again and varchar. We have price as a float, which is again a non-null. So each column needs to have a specific data type. And then one more thing to add on this, let's say Oracle might have some more number of data types, MySQL might have less number of data types than the SQL server. So you have to go through the documentation of each SQL variants. You need to work on that. Right. So this is how you create a table. One thing which we need to see over here, most of the time when we work on the table, it's always recommended to have a primary key. Now, what is a primary key? Primary key is used to, let's say, create a unique record out of this whole row. So right now, even though ticker is unique because I did delete the duplicate records out of it, but generally when you have a data, right, it's always recommended to create a primary key as well. The reason being, the primary keys basically allow us not to have a duplicate record. First of all, that's the first one of the scenarios I would say. The primary key is again a column, but that column will not have a duplicate entries, right? So based on that, what you can do basically when you filter the data, you can specifically say that this is a where clause, and where clause needs to have this filtration. So that's how the primary key come into play. I will go more deep into primary keys, foreign keys, and some other constraints in the coming videos. In the earlier days, libraries, they had the catalogs. So there were like file cabinets filled with the cards, which had the information on where those books can be found, right, in the library. So you could look up a book by the name, and then that corresponding card would indicate where in the library you could find that particular book. Because using the catalog is much easier than walking down the lane, I would say, or let's say walking down the library and looking for that particular book out of, let's say, thousands of books. Indexes in relational database it serves the same purpose as the catalog in the library. So the create index command, which you can see over here, right? So create index command lets us build an index so that we can quickly look up the rows and the tables. The syntax is something like this: create index, and then we start it with by let's say the IDX. So let me try to run this. So it has run. So now if you see, so we have created a IDX ticker. So but what it does basically, when you have millions of records in the table, it is very much easy. Let's say the data has already been indexed, so it will be very easy for the system to look for that particular data in from that particular table. Right. Now, if you see, there are two syntaxes over here. One is create index and then the index name, and then you have create unique index. So the difference is basically the index here, the columns can be duplicated, or what I mean to say is there can be a duplicate data when it comes to combining multiple columns. But here it should be a unique one, right? So this is the major difference. Third is the view. So basically view is more of like, let's say it's a virtual table, I would say, but views are mostly created out of, let's say, a select syntax. So for an example, when I'm let me take one of the queries, let's say this one, right? So we have select star from extended, where, let's say, ticker, my mistake, so NSE. So now if I'm filtering it with, let's say, Edelweiss or maybe, right? And then if I say this one, now why do we create a view is basically because I do not want to run this query again and again, right? And the thing is, next time when I want to see the data out of this whole table, and I want that data to be having ticker as Edelweiss or Edelweiss, then I should be able to run the views, right? Or view. So basically the view can be seen over here. Right now we don't have much of the view, but this is our system generated views. But if you right click over here, or let's say new view, so you can create a view, let's say for extend NSE, right? Close, and I want to see the ticker, description, price, volume, and then let's say the ticker, this one, right? And then I'm saying where ticker is equal to this one, right? So now what will happen basically, and I'm saving this view underscore Edelweiss, right? I'm just giving it a name. You can do a better, let's say a view name. I'm just saying 01 Edelweiss. Now I'm saying okay. Now what will happen? I'll show you something over here. If you come here, refresh this, now you will see a view over here, right? Now this view is a filtered view, right? How it is, I'll show you. Now I'm saying select star from Edelweiss. This is the view, if you notice over here, and I'm saying F5. Now you will see only those columns which I selected and the filtered data which will have Edelweiss only, right? Why? Because I created a view query, right? So this is let me just create this instead of alter. So this is, you can ignore this. You don't need. Now this is how you create a view. Basically, you said create view and then the view name, right? And then you are selecting the ticker, description, price, volume, sector, and from this table name, and this is the where condition, and then you can create a view. Now, last but not the least, we have, after this view, we have schemas. So basically, schemas are it's basically a structure of overall database, right? Like I mentioned earlier. So schema is a big picture of your own data, right? So you will have table, views, indexes, and all, right? And some other data structures. So you can think of it as a container of tables, views from the same, or let's say different databases. And then most likely in your everyday work, you'll not be using schemas, because once it is created, you will be just let's say using it, right? So but you will not be creating or editing any schemas. But schema is a really important concept when it comes to SQL, and then sometimes it is being asked in the interviews as well. Schemas can again be created, right? I'll show you where is it. So this is where you create the schema. So if you see over here, we will have a couple of schemas. So one of the schema that I created while creating the database was the DBO, right? So in the similar way, you can create any other schemas as well. So what I normally do, whenever there is a new application that needs to be created and then the data is somehow not connected with the existing tables, then I create a new schema, right? So and then yeah, the owner can be someone else as well. Now one of the other thing is this go statement, right? So you may have seen this go statement, or let's say this go keyword many times. So basically go it signals to the server the end of the query batch. So basically it says that this is where the query is ending, and the basic normally this go is not required, but overall it will improve the readability of your code and the performance, I would say. Let's say for an example, if you have several query statements enclosed with the go command, then one of the statement will fail upon execution, then the changes made with all the other SQL commands in the query batch will also be cancelled. And then you might have seen somewhere like the semicolons over here, even though it's not mandatory, but it's a good practice to use the semicolons. So yes, I think this is all for this video. Thank you so much. Have a great day. Take care.